Hello, this video is section 6.1 from the Larson book, Confidence Intervals for the Mean, Population Standard Deviation Known. So what we're doing primarily for the last third of this course is a branch of statistics called inferential statistics, where are you using sample data to make an educated guess about what you think the population value would be, since in many cases it's not really possible to collect enough data to get all the data to get the population mean. So we try to make our best educated guess here. And for the mean, the most basic estimate you can get is called the point estimate. The point estimate is a single value estimate for a population parameter, and what the most unbiased point estimate, and unbiased point estimate is actually a statistical term. It's not just the word unbiased, it actually has some math behind it too that we don't have to care about, is the sample mean. An interval estimate is an interval or a range of values used to estimate a population parameter. Now the problem with a point estimate is that you might guess on the high side, guess on the low side. It's kind of hard to pinpoint. Of course, most of the time you're guessing at something you don't know what it's going to be, but still, an interval, creating an interval, a range of numbers, gives you a better chance that your actual population parameter will fit in an interval instead of just guessing one number here. So we're going to see how this comes up later, but here's an example. Suppose the sample mean was calculated to be 12.4, and then we'll see how the margin of error comes about. But the margin of error is subtracted two different directions, low and high, so you come up with this interval between 10.3 and 14.5, and you're estimating that your population mean will be in that interval. Now, to what degree of probability do we think that's going to happen? And that's the next term here, the level of confidence. C is the probability that the interval estimate contains the population parameter. So they're going to be high percentage values. High is in close to 100. So like 90, 95, and 99 are three of the most common ones. 95 is probably the most common one, but you don't have to know that. So let's just use 95. I'll just say here for an example. So if you construct this interval, once we see how to do it, and it's a 95% confidence interval, that means you've got a 95% probability that the population mean will be in that interval you created. So therefore, there's a 5% chance that it's not in there. Of course, you don't know that, but that's what we talk about this being, educated guessing. That's what we're talking about. Now, this really on the right doesn't necessarily mean anything other than it's just kind of showing you an example. Now, a 90% confidence interval doesn't mean that every 10 that you do, 9 will be right and 1 will be wrong. It just means if you took all possible samples from a data set or a large number of samples, I'll just say, not all possible, large number of samples, 90% of them will contain the population mean. So on average, 9 out of 10 will, but it doesn't mean exactly 9 out of 10 every 10 you do. So what they're trying to show you here is for this third one. See, they're saying somehow, what if we found out what the population mean was by some miracle or whatever? It doesn't really matter, but these are all showing different confidence intervals where the dot represents the sample mean, and then the margin of error stretches it out. And you see there's the population mean mu right there in the middle. So you see that every confidence interval overlaps that mean except for that third one right there. So that's just showing of an example of one that actually missed. But you don't know that when you calculate it. So here it's just kind of showing you that they can be written in parentheses or with the inequality notation with the mu in the middle and then less than symbols. Either way is the correct way to express a confidence interval. So the lower end is going to be the sample mean minus E. The upper end will be the sample mean plus E. Okay. E being once the margin of error. Now here's a question saying, okay, what if they give us a confidence interval and can we figure out from that information given this interval what the sample mean x bar is and the margin of error is? And the answer is yes, we can. For any confidence interval of the mean, the sample mean will be right in the middle of the two numbers. It's right in the middle because you see up here you're subtracting the margin of error and adding the margin of error, and it keeps the sample mean right in the middle. So all you got to do is add these two numbers together and divide by 2. So that's simple enough. Add those together, divide by 2, you get 40.4. That's your sample mean. Now there's two different ways, actually 3 different ways. I'll tell you the third way that you can get the margin of error. Since it's the same distance to either end, you can take the sample mean, 40.4, and subtract the 33.2 and get 7.2. You could take the larger number, 47.6 minus 40.4, subtract, and you'll get 7.2. Either way, you don't need to do it both ways, but its margin of error is 7.2. And I'll just tell you the third way. I don't have it written down, but I'll just tell you what it is. Another way to do it is subtract the two numbers and divide by 2. Don't confuse that with the sample mean, where you add them and divide by 2. But I promise you, if you take those two numbers and subtract them and divide by 2, I promise you, you'll get 7.2. I usually like to put one of those on an exam. Now here's the actual formula to get the margin of error. I think we'll be using technology for the most part, so you won't have to worry about this too much, but I'll probably have some examples in my notes where I'm still kind of keeping this in there just so you can see it, even though you don't have to do it. Now this Z alpha over 2 is called the critical value. Some books it's Z alpha over 2, I think this book it's ZC. I just kind of like to use them interchangeably so I can use these same notes with different textbooks. And so it's the same thing, Z alpha over 2 or ZC. It's the critical value. Okay, let's come down here. Now, the difference here, see on the area under the normal curve, for confidence levels, the area is the part in the middle. So this, like for example, 95% means 95% in the middle. So this is different than percentiles that we learned. Percentile meant the whole area left. However, to use the technology, we have to convert this to area to the left, and it's I'll just sort of explain it here, but I got an easy way to do it right here, so you don't have to worry about it. But the idea is, just so you'll know, if 95% is in the middle, that means there's 5% left over to total, and so each side it's symmetrical, so it's going to be half of that 5%. So which half of 5% as a decimal is 0.025. So to convert this to percentile, 95% confidence level is the same thing as a 97.5 percentile. But instead of doing it this way, if you do it like this, now notice I have this wrapped in parentheses, inverse norm, and then we'll see it in Excel also. But it's 1 plus the confidence level. So if it was 95%, you just put in 1.95 divided by 2, and that's the inverse norm in the calculator. Then we'll see what Excel is here in just a second. Now this is using, like I said, this is using the normal chart. I think I have it in D2L, and you would go inside here and you'd look for the value or the closest value. That's not always going to match. You just look for the closest one, but you don't have to do it this way. If you see inside the table 975, it's in the 1.9 row and the 0.06 column. And you see the inverse norm result right here. I did inverse norm, 1 plus 0.95. See how I wrap parentheses around that? A lot of times people, they don't use parentheses and they go, why am I getting these wrong every time? It's because they're just putting in 1 plus 0.95 divided by 2 without the parentheses. Because if you don't put the parentheses, so here it is with parentheses. Actually, you can just put 1 plus 0.95 is just 1.95, but always just do it this way. Then so you notice I did that actually just within the inverse norm command, but you can do it first But, you know, I've had people in the past, you know, they do this. And, oops, that's no good without the parentheses. So we need that parentheses. Oh, I was going to do, let's do the Excel for that one. And we've got several examples. It's just like it is for percentiles. It's the norm S inverse. And if you want to type it the 1 plus 0.95, you can. Now let me insert this column and put the formula text command here equals formula text B1, just so you can see it clearly. There we go. So now we can do this like this one, either do it in the calculator or Excel. So yeah, that one's, it may have the 0 on the 1. It doesn't have to have the 0 on the 1. But I'll just do it here real quick. And of course we'll see examples in the homework. But so that way I could ask you then, what's the critical value for just any, you know, random confidence level? So B1 plus 0.82 divided by 2. And then we have 0 and 1. Paste. Enter, and we have 1.34. At Excel, I can just change this command right, the same thing, to 0.82. Hit enter. 1.34. That should be our answer. 1.34. Actually, let me, when I bring up this Excel file here in a minute, we may not even have to do this way anymore. Okay, so here's the formula that we're not really going to have to use, whether it's a calculator or Excel. So that's that part we already talked about. That's your margin of error. So it's the X bar, the sample mean, minus the margin of error, X bar plus the margin of error. Okay. Now I've got this first one done using the formula and punching it. Just to show you, you're not going to have to do it this way, but just so you can sort of see where it comes from. So this example says from a sample with 35 days in a recent year, closing stock price from Hasbro has had a mean of 2320, population standard deviation 4.34. Find the 90% and 95% confidence intervals for the population mean. Which interval is wider? Okay. So I just wrote these values down, and you can do that. See, here's the inverse norm, or I could do the same norm inverse thing in Excel for 90%. I can just take it over there real quick. Okay. A lot of books will use, 3 decimals for that one, just because a lot of times they'll use 2, but some of them will use 3, and this one makes more sense to use 3. 1.645. So you see, I'm just following the formula. Your X bar is your sample mean that's given, 2320, plus and minus. You know, it says plus and minus, you're doing minus first because an interval is always going to be lowest to highest. And there's the 1.645 right there, times your standard deviation divided by the square root of n. So if we were doing this way, this would not be that difficult. But we're not going to have to do it that way. But just wanted to show that to you. So let's come down here and see how both technologies are used here. So I'm going to walk through the calculator here real quick on this one. Okay. We go stats, test, and number 7, Z interval. So we're using a Z process when the standard deviation is known. And well, I want to mention something else too, but let me finish the problem. Okay. Let me see if I can remember what those were. I move the calculator over so I can see what. Oh, I don't want. 4.34 is the standard deviation. 23.2 is the sample mean. N is 35. Confidence level, now see if you put 0.90, what happens is when you move the arrow, it just drops the 0, which obviously mathematically they're the same thing. So you could just put in 0.9 if you wanted to, but obviously if it has a second decimal place, it's not 0. It needs that in there. You hit calculate. There's your answer. Oh, wait. Well, okay, let me just bring it up. It should be there again. I don't know what I hit and got rid of it. I didn't mean to. Go down and hit calculate again. Somehow I got rid of it. There it is. Matches box number 4. Okay, now in Excel, I created some formulas using things I had within it. A nice, neat way to do this, and in your D2 and D2L, so in D2L we go over here to content and charts and Excel files, and we want this one. Now there are lots of statistical programs that will do this more conveniently, and let's see, I'll make sure that we can download this. Okay, where's the, yeah, I've never opened it. I've only opened it from my flash drive. It looks like it'll be okay. All right. Not too well. I'm going to, but you don't ever have to save any of these, because it'll open right back up whatever it was, and there's no numbers that are saved here. But I just kind of used various commands here, plus the built on the formula. Other software packages would already have a nice, Excel just doesn't already have it nice set up like I set it up here or whatever, but other programs would already have it where you enter everything in like the calculator does exactly too. So, but this is pretty easy, I think, to follow. So yeah, this has been a good thing for students to have. I just thought one day, I said, I need to write a program for this. So this is confidence interval 1 mean Z distribution right here at the bottom. That's so the tab on the bottom tells us where the T distribution is actually going to be the next section, and proportions will be after that. So what was our problem here? Let's see. Let me see if I can get everything on the page here. We had put this on the right side of the page. Okay. I can't say everything's in the same exact order. It's not as the Excel program, but we can get, I mean, the calculator entry, but we can still get everything right off there. So we come over here, and our confidence level is 0.90. Sample size, so it's not in the same order. So just be, you know, well, you wouldn't be doing this both in the calculator and I wouldn't think you would be doing both, you know, one or the other. You're just picking the numbers out from the problem. 23.2, and the population standard deviation is 4.34. Hit enter. Let me scroll over so we can see that. And then there, see, there it is, 21.99 to 24.41. Yeah, one thing I want to mention, I noticed that earlier when I was explaining, you know, the inverse norm stuff and the critical value. Actually, if you're only getting the critical value, like I did that 82% problem, I forgot that was already set up in here. So really all you'd have to do, if you just wanted the critical number, I've already got the inverse norm over there. If you just put in, I'll use the 0.82, hit enter, don't worry about the other numbers. Over to the right, there's that critical value right there, 1.34. So yeah, I forgot about it. Wait, that was fine. We just typed in the norm inverse, but you can just do it this way if you want to use Excel. All right, so let's come down here. All right, now we'll make this larger. Yeah, we want to do this to 95%. I wrote the formula out, and the only difference in this calculation is you have a new critical value Z. And I did it right there in the calculator, 1.96 for 95%. And you're entering everything in there the same. So the calculator should probably already have everything in there. All I got to do is change one number. So if I go stat, test, Z interval, and I just have to, I just changed the confidence level down here to 0.95. Hit calculate. Okay. And then I'll move this over, but you can see it's you see it's 21.96, 21.76. There it is right there. 24, roughly 0.64. Now to determine which of these said which interval was wider. Well, let's do it for this real quick. So all you see is just I can go to spreadsheet and just change the 0.82 to 0.95. And there are the new numbers, 21.76 to 24.64. All right, nothing to it. So let's take a look. Now, wider means, you know, the distance between the two numbers. So if I take the 90%, I get this width of 2.42. FYI, the width of the interval is actually twice the margin of error. You don't have to necessarily know that, because if you're going E one way below and E above, it'd be two E's added together. Well, they'll be easy to see from this one. If you subtract the two numbers, this width is 2.88, so it would actually be this number right here. If you rounded it to 1.44, multiplied it by 2. That's what I'm saying. That's twice the width. Anyway, it's wider. Okay, now we're about to learn that we could have answered that question, which one's going to be wider, before we even started the problem. Yeah. But now, I mean, that's didn't hurt that we didn't know that, but now we will. So the width of a confidence interval is determined by the margin of error, not the sample mean. The sample mean just sits there in the middle, and then it can be stretched out, the interval stretched out based on the margin of error. So it just sits there as a fixed point in the middle. So it's whatever affects the margin of error is what affects the width. So sample mean has nothing to do with, sample mean is an important part of getting the confidence interval, no doubt. But the width is affected. Now I'm going to assume that we really can't affect the standard deviation, but you can affect the critical value, because if you were doing a confidence interval, you know, if you were doing this on your own, you could choose, okay, well, what if I want 90%? Maybe I want 95%. You could change that to what you wanted, and then sample size. Perhaps you could say, well, maybe instead of a sample size of 100, I could possibly increase that to 200. You know, maybe I can get, you know, bring in more data. Maybe that's possible. So, so we're going to assume those are two things that you can affect. Now, increasing. Now I have these. The way I have this written is the two in red work together, and the two in black. So increasing the confidence level will increase the width of the interval, and therefore decreasing would decrease. So in other words, this question was already answered before we even started, which was going to be wider, 90 or 95? 95, because it's the larger. See, when you increase the confidence level, this number gets larger. That critical value gets larger. It's getting larger as you increase the confidence level. I'll go into Excel for a second here, just real quick. You see that was 95, 1.96. If I change that to 0.97, that Z critical value, and that goes up to 2.17. Changes to 99, goes up to 2.57. So you see it increases. The Z critical value increases as the confidence level increases. So it makes the margin of error wider. Let's see. Now you might, let's look at the other part of this. Sample size. Sample size has the opposite effect. If you increase the sample size, you will decrease the width of the interval, mainly because the sample size n, even though it's the square root of n down here, it's in the denominator of that fraction. And anytime you increase the denominator of a fraction, it makes the fraction get smaller when you increase the bottom. So it decreases it. So they have opposite effects on each other. So the idea, if someone doing this, you know, you might be thinking, well, why wouldn't you always just want, you know, the higher confidence level means you have a higher probability that the mean's going to be in there, but also makes your interval wider, meaning it's less precise. In other words, if it stretches out farther, it's, you know, it's less precise. It's a bigger range. So that's where a statistician would have to kind of make a trade-off. You know, are they more concerned that it fits in there, or do they want the interval to be a little more narrow or more precise? And that's where the sample size comes into play. Let's say you're determined that you want this to be 95%, and you want the interval to get narrower. If you can possibly collect more data, that would decrease the width of the interval and make it more narrower, meaning it's called more precise. And that's a general rule of thumb in statistics and inferential statistics that we're doing the rest of the way here. If you know, anytime you can increase the sample size, that is good, because it makes your results better. And it kind of makes sense. You know, the more data you have, the more likely you're going to get better results. All right, let's take a look at this problem. I do want to mention one thing before we start these examples. There's kind of two schools of thought on this, when to use a Z distribution, and the next section will be the T. I'm using this school of thought of knowing the population standard deviation, but the book talks about, this book, you know, some do it this way, some do it the way I'm doing it, where if kind of ties into the central limit theorem. If your sample size is at least 30 or more, then you can use the Z distribution, but some people disagree with that. And I'll show you in the next section I'll compare a couple things and show you. Now, if the sample size is really large, it's going to be the same. But anyway, long story short, what I'm going to do to make sure I accommodate both methods for you is I'm going to make sure that the problems that relate to this section versus the next one, I'm going to make sure it says that the population standard deviation is known, and I'm also going to make the sample size more than 30. And I'm going to cover both methods that way. That way there won't be any confusion. So if you happen to look at the book, some people look at the book, just out of curiosity, they'll be talking about, more than 30 use the Z. But yes, that'll be true because mine will be more than 30, but they're also going to give the population standard deviation for those same problems. So that way it should be okay. So 52 football players, 252.5 is the mean. Standard deviation population, 31.1. Determine 80% confidence interval for this sample. Okay, I've got the formula written out here manually. You do not have to worry about that. Let's look at the technology. And some of these I'm just going to kind of explain because, like I said, we'll do fresh examples in the homework. Just to save time in the lecture here, I won't necessarily punch in all of these because you're going to see it done anyway. So it's Z-interval stats. The population standard deviation is 31.1. Means 252.5. Sample size is 52. Confidence level is 80%, 0.8. Then you hit calculate. And there you get it right there, 246.97 to 258.03, which matches what I've got using the formula, which you do not have to do. Now let's look in the Excel spreadsheet. Confidence intervals for the mean, population standard deviation known, confidence level is 0.8, sample size 52, mean is 252.5. Population standard deviation is 31.1, and then so it gives you that critical value, gives the margin of error. So if the question was asking margin of error, that would be right there for you. To get the margin of error from the calculator output, you can do it one of those two ways I could do you, or the way I explained that it wasn't written down. You can subtract these two numbers and divide by 2. That'll give you the same 5.527 right here. So that would be, if you were using the calculator and you wanted to get margin of error, that would be the way to do it. Here's another one. 30 students as your sample size. Mean score is 93. Assume that, so it can say either population standard deviation or show that little sigma character right there. Because that's that little O with the hook. That's the Greek letter for population standard deviation. And we want to construct a 99% confidence interval. Okay, so Z-interval stats, 12.2 is your population standard deviation. X bar is 93, N is 30, confidence level is 0.99. Calculate. And there it is, 87,263, 78, 98,737, which is kind of what I got right here using the formula. Let's check out Excel. 0.99 is your confidence level, 30 is your sample size, means 93, population standard deviation 12.2. And then there they are, got them highlighted in yellow, 87, 263 to 98,737. So either way, works beautifully. All right, here's the old school way, sort of over to the right. Don't have to worry about that. Okay, sample of 77 light bulbs. Mean life of 472. Population standard deviation is 38. 90% confidence interval for the mean. All light bulbs of this type. Okay. Pretty easy peasy there, I think. Put in 38 for your standard deviation. 472 for the mean. 77 is your sample size. 0.9 for 90%. Calculate. There it is, 464.88, 479.12. So rounded to one decimal, it would be that answer right there. Okay. All right, let's see. Calculator. Excel, I mean. 0.9, 77, 472, 38. There are the answers there. You can see them right there. Same as the calculator. Just the calculators are obviously rounded to two decimal places. Okay. Not that it matters, but I'll mention it anyway. But you might notice there's a slight difference between this answers and that answers. That's because I'm using a rounded critical value. You see that Excel does it where more precise, so it's using this critical value. So it's just making it slightly different, but it's not really affecting the answer greatly or anything. Okay. Let's see what we got here. This is just kind of a conceptual question to see if we understand the idea of confidence intervals. What are we actually doing here? So we're taking a sample of 250 students at a university, take a mean of 14.2 credit hours per quarter with a standard deviation of 2.5 credit hours. The 99% confidence level for the mean is these two numbers, credit hours per quarter. Interpret the interval. So one thing to keep in mind, what we're doing is we're using sample data to approximate an interval that where we have a 99% chance that the average of all students fits in the interval. So I'll look at the right answer, then I'll go back and look at some of the wrong answers. So the right answer here is C. We're 99% confident that the average number of credit hours per quarter for all students, keyword being all. So we're using that 250 to that falls in this interval. So if you took all the students, which I'm sure that obviously the school could do it. They wouldn't have to do it this way because they would obviously have a database where they could just average all that. But I'm saying if just somehow somebody was just collecting data on their own and didn't have access to the computer system. And now let's go back and now this A is wrong. 99% of the students take between those credit hours per quarter. That's not what it means. We are 99% confident that the average number of credit hours per quarter of the sample students falls in the interval of 13,793 to 14,607. Well, that's wrong because it says right here the sampled student. See, we're 100% certain, since the sample mean was 14.2, we'd be 100% certain that sample mean would fall in here because the interval was created based on that 14.2. But see, that's the idea. We're creating the interval from the sample to approximate the average for all the students. I should say estimate, excuse me, instead of approximate. We're estimating what we think it is. And then the probability that a student takes between these credit hours in a quarter is 0.9. That's just not quite right because it's once again it's an average. It's predicting the average for all students. That's not the probability of one student being in this interval. They can be all over the place. We're only interested in what the average is, not what one student would be. Okay, that was fun. Okay, so I just kind of talked about that, but you can read that if you'd like, so I'll skip that. And then the last part here is finding the minimum sample size to estimate the mean. Now, suppose that you not only are you determining what confidence level you use, that you want, if you were doing this as a practicing statistician or whatever, and let's say that you want to have a predetermined margin of error for whatever reason. Let's say I want 95%, and I want my margin of error to be 3, plus and minus 3. What would be my sample size needed to guarantee that the margin of error is 3? or even less, maybe if you went higher than that, of course. But let's say 3. There's just the minimum to get it to 3. Now here's the formula. And the formula is just, if you took this formula and did the algebra to it and solve for n, which you don't have to, don't worry. You solve for n, you'd get this formula right here. And just like when we did the class width in a frequency distribution very early, that was probably the first section we did, I think, wasn't it? You have to round up to the next, and these have to be whole number answers also too, because you know, whatever you're sampling, the number of items needs to be a whole number, but you still want to round up. So whatever it would be. So like, for example, 49.1 would be 50, 49.8 would be 50. Okay, determine the minimal required sample size if you want to be 99% confident that the sample mean is within 2 units of the population mean. Now, given that the population standard deviation is 1.4, assume the population is normally distributed. Okay. I think that sentence is in there because these kind of answers may come up to be less than 30, which is okay. But like I mentioned earlier, when we're doing a confidence interval, I want to make sure that the n is more than 30, but it might be less than 30 for these. Now, sometimes they'll flat out say margin of error or E or something, but the way you interpret it is in something like this, where it says within 2 units, that's the key phrase, meaning your margin of error is 2. So it might just come out and say margin of error, which obviously would be nice, but within 2 units is your key phrasing for the margin of error. And you see I have the 2 right now. Now the calculator doesn't have a built-in function, as I mentioned here. So what you have to do is you do the inverse norm to get your critical value, and then you'll plug it right into the formula. So there's the formula. So here, okay, I have it right here. I did inverse. You can't see the rest of it, but inverse of 1 plus 0.99. Maybe I will put it in the calculator. At least divide by 2. Okay, so just kind of cut off the screen there. Second distribution, inverse norm. I'm just going to put, okay, well, I just already have it in here. I was just going to put in 1.99 instead of doing 1 plus 0.99, but that's okay. All right. Now, I'd use quite a few decimal places here. I used 4. It might not even hurt to put another one in there. Like 2.57583 would have probably been good. I'll do that right now. So the formula over here is, well, let me go back up here. It's your critical value that we just got from the inverse norm times the standard deviation divided by the margin of error, and then you have to square all of that. Very important that you square it. I'll see people forget this. They'll do everything right except for the squaring part. So you see how I put it in the calculator. I put it all in parentheses, so it'd be squared. So I'm going to go 2.5758. I'm going to add a 3 there for that 29, just to make it. I don't think you have to do all the decimals in there. You can if you want to. The 1.4 was the standard deviation, and then I was mentioning that the margin of error was the phrasing using the within 2 units. All right, so where's my square key? It's over here somewhere. There you go. And we round up. 3.25. We round up to the next integer, so the answer would be 4. Now Excel is nice because I wrote a program for it. Where I wrote it where it does that last line just does the same calculation that I did in the calculator. I mean, it's nothing that special, but I mean, it can be a time saver. So it is on the same first tab. You see, there's 2 things here: creating confidence intervals, doing the minimal sample size. Oh, it looks like that one's already in there. So Margin of error is 2. 1.4 is population standard deviation. 0.99 is the confidence level. I must be rounding these to 4 decimal places because there's more decimals than that, but it doesn't matter because what it's showing here because of whatever it's doing in the calculator. So that's actually the formula. You see, I discovered a round up command that takes care of the rounding up for us already. And then your sample size 4. Isn't that delightful? All right, cholesterol contents of cheese. Okay, you see the within 0.5 milligrams? Within 0.5? That's going to be your margin of error. So they want to do it for a 95% confidence interval. Confidence level 95%. We're not doing an interval here. We're doing sample size because you see it's asking to determine the minimum required sample size. And then population standard deviation is 2.8, and then we do it for 99%. Okay, so you do the inverse norm to get your number here, and that one's convenient to round to 1.96. So I did 1.96 times the standard deviation divided by 0.5, but all of that is squared. So it's 120.47. We round up, as I did right here on the top of the page, to 121. Well, not top of the page, but top of the screen, I should say. To 121. But put it in the calculator, Excel. 0.5 margin of error. Population standard deviation 2.8. Confidence level 0.95. And 1.96. And then it gives you the answer right there, 121. Convenient. Now, for 99%, we're just changing the confidence level. So in the calculator, you would just do 1.99 divided by 2, and you get that critical value. I didn't put 3 in here, but I guess you could. Guess I left it at 4. That's fine. Shouldn't affect too much there. Times 2.8 divided by 0.5 squared. Everything else was the same. 208.06, which you would round up to 209 right here. Put it in Excel. 0.5, 2.8, 0.99 confidence level. That's showing you the critical value, and then showing you the result for the sample size. 209. And this kind of works on the same premise as if you're increasing the width of an interval. Yeah, the higher the confidence level, it will require the larger sample size. I mean, the larger sample, will produce the larger sample size. I should say not require, because we're calculating the sample size. So the larger confidence level gave us the larger sample size. All right. So that concludes the lecture portion. So let's take a look at some homework. Here we go. I'm going to skip some of those kind of conceptual questions and let me just look through. How many do we have? 7, 8, 9. 9 of them. I'll see if there's anything weird looking here, but I can do this one real quickly. It's in calculator. I'll just do some of the ones I'll do both Excel and calculator, but I'll just do Excel for this one. But what was it? It was confidence level? 86. So in the calculator, you just do inverse norm of 1 plus 0.86 divided by 2. Spreadsheet's real easy. Come back up to the top here. Like I said earlier, we don't need the other numbers below. Just change that to 0.86, and the only thing we care about, it'll give you the critical value over there to the right. There it is. Oh, how many decimals does it want? Always have to be careful with what it wants, don't we? 2. So 1.48. Beautiful. Let's see what's next here. Yeah, they're bringing up that chart. If you need that chart, I'd probably recommend using Excel for this one. If not, you can do it with the margin of error formula. I mean, I can do it that way, but in the calculator, if you want to see it, but I guess since this isn't a live lecture, I can't get any answers, can I? But you have to do the 90%. You have to do so you can go inverse norm, and second, and it's 0.90, and arrow down till we get paste, and it's in the notes, but the margin, I'll expect you to know this off the top of your head, obviously, but the margin of error formula is going to be that. Yes, you can scroll back in the notes and see it. Oh, I don't know how many decimal places we need for this. 8.5. It's your critical value times the standard deviation, which you see is 3.1, divided by the square root of n. And n is 81 for this one. Three decimal places. I like 0.567. Excellent. I don't want to go off this question because I'm about to put the same thing. I want to minimize this. I'm going to put this on the left screen. Now, I'll have to scroll over here. That's okay. You know, some of there's margin of error over there. Confidence level is 0.90. Sample size 81. Now, I'm not doing anything with a mean. I'll explain that here in just a second. See, there it is, 0.566. See that mean? I'm going to change it to something different. 60. Let's go over there. Margin of error, look at that, 0.567. The margin, the sample mean, obviously is a very important part of creating a confidence interval, but it has nothing to do with the margin of error. So that's why I didn't even have to even consider that. So if there's, whatever number is there, just leave it. If you're doing it this way in Excel, really just leave it. It won't matter. It's going to give you the correct margin of error. Now, obviously, the confidence interval, then you have to use the margin of error with the correct sample mean. But no, just for margin of error, we don't need the sample. There didn't have to be a sample mean. Pretty exciting, huh? All right, let's do maybe a couple quick. Okay, that's just kind of. Okay, this was in the notes near the very beginning, where I told you if you had a confidence interval, how to get the margin of error and sample mean. So go back and look for that example early on. Okay, I just kind of wanted to pick something out that had words to it. Let's see, this one looks like it's doing a 90 and a 95, but I'm going to come back to number 8 in a minute. Oh, yeah, I'm going to make sure I do it. Yeah, number 9 has a sample size, so I wanted to do that also. Number 8, if you look at part C, I mentioned in the notes lecture there that, I don't see how you could possibly affect the population standard deviation. So, and I wouldn't ask that on a test. I would only ask, something relating to A or B. But I'll go back to this and show you, just for the purposes of this assignment. Where are the notes here? Yeah, I did not address that because I didn't really think that that was even possible. Well, I mean, I don't know, but it doesn't matter. I wouldn't ask it on a test. But to answer that homework question, I'll be happy to tell you how to answer it. Yeah, here we go. I don't consider it to be. But anyway, long story short, see, even though that Z alpha over 2, the confidence levels to the side, it's still up in the numerator with this value right here. So since the behavior of the standard deviation will be exactly the same as the confidence level, if you increase the standard deviation, you increase the width. So the standard deviation works exactly like the confidence level, and then the sample size being on the bottom works opposite. All right, so now you can answer that question when you get to it. And where'd my preview go? Is it? Oh, it's probably the split screen, so there we go. All right, so I won't actually work that one out. I'll leave that one there. Let's do number 7. 90%, so 55, mean price 138, population standard deviation 19. I'll use both methods. So on the calculator, let me do it. Oop, get back up there, Wabbit. And we have stat, calc. Oh, wait, test. I'm sorry, test. Excuse me. Number 7, C interval. Stats. Stats means you're entering. We'll be using the data for the T interval in the next section, but showing an example of that. But for this, it'll be stats. So what's the standard deviation? 19.2. Obviously, I don't have to put the 0 at the end. Sample mean says 138. N is 55. Confidence level for the part A is 90%. Calculate. It wants 2 decimal places. So let's try 133.74 and 142.26. Let's check answer. Look at us. We're too cool. But before we move on, let's put this in Excel. I could have done either one of them first, because obviously if I do one of them, I'm going to verify it with the other method. So I could have done Excel first, then calculator. So, all right. Okay, it's already split screen for me. That's good. 0.9 is already there. Sample size 55. Uh, 138, 19.2. There they are, the lower and the upper. So rounded 2 decimal, 133.74, 142.25. I'll tell you what I'm going to do. Because this is still up on the screen right now, I'm going to do this method first for the 95, and then I'll go back and show you the calculator. That'll be easy to do too, but this is right up here, so let's do it. Let's change that to 5. Let's go over here and see what our new interval is going to be. I like 132.93. Okay. 143.07. Good job. And calculator. That'll be super easy also, because we'll go set, test, Z interval, and the previous data should still be sitting in there, and it is. Just change the confidence level to 0.95. $132.93 to 143.07. All right, now let me expand this so we can read this conceptual question. All right, okay, let's make sure the wording's not too tricky here. Well, we know the 95, okay, actually I read the last sentence first. The beginning of that sounds right until you get to here. Yeah, this is no good. We learned earlier, right, that well, obviously we can look at the answers, but we don't have to do that. We already know that when the confidence level increases, the width increases. So that's definitely got to say that. So now B and C both say that, but let's see, they both say the 95 is not wider than 90, but there must be something. Here's the trick on this one. The answer is going to be C. And that was that same example, like kind of theoretical example I did in the book. This says with 90% confidence, it can be said that the sample mean price lies in the first interval. No, it's a 100% chance the sample mean's in there, but it's a 90% chance that the population mean is in there. And once again, the reason why it's a 100% chance the sample mean is in there is because we used the sample mean to create the interval. So obviously it's going to be in the interval. So that's the difference between the B and the C here. So this should be correct answer there. Got it. Let's do that, the one that has the sample size. I think that will do it for us. No, not that one. Minimum sample size. So we have to actually, well, if we do the Excel, we'll do it without having to use the calculator, but I'll show you both. Yeah, it's funny that the sample size. Yeah, it's interesting because, like I said, I'm showing you both ways here, but there's probably people screaming into the video. Just show me the Excel only, or something, or just show me the. I'm just trying to be patient with me. I'm trying to show both, So, but you'll get to see whichever one you want to do. So, but if you want to scream at the video, it makes you feel better. Not going to hurt anything. Okay, what do we got here? It said within. See, there's within 0.7, so that's your E. So let's come over here. Margin of error, 0.7. I'll just put 0.7. Same thing. Where's my standard deviation? Is 0.75. 0.90. And I like 4 for that one. Okay, I can pop this in Excel real quick. Excel, I mean the calculator. So we'd have to do inverse norm of 1 plus 0.90 divided by 2. That's already there. And the margin of error formula. I'll show you in the notes here. Yeah, no one's expecting you to have that, like, obviously memorized or anything. Yeah, there's the margin of error formula right there that I used already. The sample size was down here. There we go. So it's the critical value times the population standard deviation divided the margin of error all squared. So if we go to the calculator, or for just, I don't know, for accuracy, 8.5, that's good enough, times the standard deviation, which 0.75, is that it? No, better not try. 0.75 divided by the margin of error, which is 0.7, squared. 3.1 blah blah blah, round up to 4. So you have to round that up to 4. Yeah, I certainly don't mean to sound biased in any way, that biased in one way or the other, but I really like to excel for that, for myself, but that's all right. You do whatever you're happy with and makes you successful. So let me put this a little bit bigger so I can read this. All right, part B says sample mean of, okay. All right, so it's a little bit different kind of question here, but we'll take care of it. So once I explain it here, you'll know how to do it. We're doing a confidence level now, 90%. So I'll just toggle back and forth here. So I know that's 0.90, and that was 7. And let's get these numbers. And okay, 0.75 again, standard deviation, means 128.25. What we get, 128.25. And then that was 0.75 again, right there. So it should be asking the interval. What's it going to be? Two decimal places. So 127.78. Oh, that doesn't feel right what I'm typing here, but I'll double check it. There we go. And then 128.72. Okay, what we're trying to establish here, and like I said, I didn't really talk about the notes, but we'll just take care of it right here in this problem. What it says, does it seem possible that a population mean could be exactly 128 ounces? So what you're looking for here is the number they're giving you there, in which is case 128, is it within your confidence interval? So the answer is going to be based totally on if it's in there. So if it's in there, we're going to say it does seem possible. So I don't know what could happen on these. When you get new numbers, it doesn't mean this is going to be the exact answer, because I'm just telling you what's determining it. You could get different numbers and it might not be within there, and you would pick it does not. So 128 fits in there because 128 falls inside the interval. So if it was not, you would pick does not, then you would pick outside the interval. So that's all you have. That's all that means. That way you don't stress out on that. Now you know how to handle that situation. So well done. Well, all right then. That's going to conclude our video for confidence intervals for the mean, population, standard deviation known.